And also, Sharon is going to join me for the demo. So Sharon is going to introduce him later, too. And besides that, I also would like to introduce a few more people in TSDR. One of them is Jan Medved, very important to our project. Some of the design architecture ideas in TSDR actually came from early discussions with him, some brainstorming sessions with him. Also, another person, Munish Anumala, very important to our project. He's one of the committers, TSDR committers, and he really guided us through the Lithium, so very important too. And also, Sharon and Bashir, two key contributors to TSDR, two of the committers to TSDR, and Sharon owned data collection service, and he's going to show you a pretty sexy GUI of Grafana integration in the demo. Bashir, he's on vacation too, unfortunately, and he owned TSDR H2 data store. So without Bashir, there's pretty much no H2 data store because we didn't plan to do it in Lithium. However, he came up with this idea in order to show the architecture, the power, generic architecture of data store. He came up with H2, and he owned from end to end. He developed H2. That was amazing. And we are going to show that too in our demo. And also Vasanthan, who's our testing lead of TSDR. I really want to mention Vasanthan because as a new project in ODL, usually people are pretty much struggling with unit test coverage, those kind of things. However, we are pretty proud of what we have done from testing point of view because we went through very exhaustive, comprehensive testing, including functional testing, performance and scalability and longevity. And we are going to share the testing results in our slides too. The last but not least, Harry from TSDR team worked together with me on TSDR H-based data store. It's really great to have him on board with TSDR. The reason why I would like to mention the team first before we go to the presentation is really from my 20 years experience in the industry. People are always the most important of a project. Okay, now let's come back to our presentation. Our title is Towards Smart and Intelligent SDN Controller. People always asking me, why TSDR? What's the motivation of TSDR, right? Why we need TSDR in ODL? Well, I believe, in summary, there are three motivations behind TSDR. If we look at current SDN controller, pretty much it's static flow control, flow configuration, right? Most of SDN controllers are like that, right? However, we truly believe the next generation of SDN controller is going to be smart and intelligent. What do we mean by smart and intelligent? That means flow control or flow configuration is not a one-time thing. The controller really needs to understand what's happening in the network and adjust itself and reconfigure, re-steering of the traffic flow to optimize the network, right? And in order for us to get there, the first step is to understand what's happening in the network. And we believe TSDR, the time series data repository, is the foundation for us to get there. And the second motivation is really from the architecture of SDN controller point of view. In 2012, Rajesh, distinguished engineer from Dell Research, proposed the stats plane concept. Well, what does stats plane concept mean? Because everyone's talking about data plane and control plane in SDN world, right? However, we believe for the stats, which is basically time series data processing, we really need a separate component as well as processing platform for those data. And that's the idea of stats plane, and we are going to talk about that in more details later. So why we need a stats plane? We believe with that stats plane, we will be able to improve the scalability and performance of SDN controller. So the third one is if we look at nowadays network, it's different from before. In old days, it's pretty simple. Pretty much equipment's there for you to manage, to monitor, and to understand what's happening in the network, right? But now, if we look at current network, it's definitely much more complex, especially after NFV is introduced. If we look at NFV architecture, it's really 3-layer, which means physical layer and also virtualization layer. And then now we have even a third layer, which is virtual network functions, VNF layer, right? So in order to understand nowadays network, we need to understand all the data being generated from different layers of this complex network. And how do we do that? Again, we believe TSDR should help us to get there, right? The idea is really to have a common repository, and then we introduce all the data into this repository, and leveraging on the common data model, we massage the data, and after that, we extract intelligence and information out of it. So that's the major idea of TSDR. Okay, now let's get into the presentation. The agenda here is, first we're going to talk about time series data analysis, right? Why we need time series data analysis. Why we need it in network. Why we need it in controller, right? And the second one would be our objectives in ODL. What's our goal in ODL? And the third one is what we have achieved, in Lithium. And then we're going to talk about roadmap and the future directions of TSDR. And we are going to touch a little bit TSDR beyond ODL, right? What TSDR can do even beyond ODL use cases. And eventually we're going to show the demo. And Sharang is going to show that. Okay, let's talk about the power of time series data. What is time series data? Time series data is a sequence of data points with timestamps, right? It can be measurements. When we talk about networking, it could be port stats, interface stats, and CPU utilization, memory utilization, those kind of measurements. And it could be log files, like syslog files, all kinds of different log files recording the activities in the network. It could be events, alarms, alerts generated from network, right? And we also notice there's huge amount of time series data being generated every day. And those from cloud infrastructure, from software applications, network equipments, security appliances, and even IoT devices. Then why we need time series data analysis, right? We believe the power of time series data analysis is really to leverage in what happened in the past, which is historical view. If we think about it, it's historical view of the time series data. And together with what's happening now, which is real-time view of this time series data, and to predict what's going to happen next, right? We have fancy kind of term like predictive data analysis. It's talking about the prediction of what's going to happen next. And then, the most importantly, with all those analysis, we would like to take proactive actions, right? Again, some fancy term like prescriptive data analysis with automation, okay? Now, we also noticed time series data analysis has been very successful in many areas, including financial market, like to predict the stock price trend in the future, right? Also, weather forecasting, like everyone probably has already noticed, the weather forecasting has become more and more accurate. That's from the time series data analysis, right? Also, other fields like economics, healthcare, insurance, you name it, a lot of good application of it. Now, the goal of TSDR is really to apply time series data analysis in SDN, okay? And people would ask, why now, right? If it's important, if it's good, why it didn't happen before, right? So we believe this is because it's really good timing, because big data technologies make the time series data analysis possible in high velocity of data. Because if you look at the time series data generated from network, it's really streaming data in fast speed and large amount, right? Okay, then people would ask, give me an example, right, of using time series data analysis in networking. So this is the example. If we look at the left-hand side, that's our network, right? It can be virtual, it can be physical, doesn't really matter. But let's say, start from simple. It's physical topology, right? If we look at that, in order to send flows from A to F, there are multiple paths. It could be direct path from A to F. It also could be two more different paths, like A to B to F, or A to D to E to F, right? So what we can do about it with TSDR? The first step, we can collect stats from network and then store into TSDR, right? And then secondly, we will leverage data analysis through the integration with data analytics engine and to generate the results. Okay, so for example, the results what we get from the data analysis would be for the red one, which is direct path from A to F. In the next 24 hours, we predict there will be congestion on this path, right? Well, the definition of congestion could be, over 90% of bandwidth utilization, right? Or it could be something else. The user can define that. And also, for other two paths, it's going to be pretty healthy in the next 24 hours, right? When we say healthy, it could be definition under 80% bandwidth utilization, for example. So with this information, what can we do about it in the network? So the third step would be, we feed back this data analysis result into the controller and give it to some data-driven applications, which can dynamically change the configuration of the traffic flows on the fly. For example, before 24 hours what we can do is we can leverage some configuration capabilities in ODL controller to redirect all the flows from A to F to the other two. Then by doing that, we can make this network kind of balanced in terms of traffic flow, and then does not cause any congestions in the next 24 hours. Okay, so this is just one example, and we can use our imagination, creativity to think about all different kinds of use cases. And here I listed a few, and I'm not going to go through all of them. Basically, that's related to traffic control, prediction, and also optimization related to network activities. Okay, so now let's talk about what is the objectives of TSDR in ODL. What are the goals, right? So the first one is related to what I have talked about from architecture point of view. We would like to help with the scalability and performance of ODL controller. And the information we got was in Helium, the time series data such as OpenFlow stats were only available from in-memory data store. There's no persistent data storage of that, right? And then that data started to drop from in-memory data store after 3 seconds in large deployment scenarios. So don't ask me what does large deployment scenarios mean. It might be 250 OpenB switches, for example. And for detailed information, probably you can ask for OpenFlow plugin people. That's where I got the information. But definitely in large deployment scenarios, there's no way to store long time series data in memory data store, right? So what we would like to do is to leverage the stats plane concept to separate the time series data processing from control plane and data plane. So that's first of our goals. The secondly would be we would like to, by providing long time series data directly from controller, we would like to encourage and enable data-driven applications built from controller, right? For example, like what we mentioned, the traffic pattern prediction with reconfiguration capabilities. That kind of data-driven app could be built on top of ODL controller. And then the third one would be, by doing so, we believe it will help with creation of an intelligent and smart controller over the time. Okay, so now let's take a look at a little bit details about what does SDN stats plane mean. If we look at the left-hand side, we can see control plane and data plane. That's all what we have been talking about in SDN world, right? Now, what we are trying to do, or trying to say is, we need a separate stats plane that's just handle, the time series data. We kind of expanded the stats instead of statistics data. We are trying to say it's a little bit more generic. It could be any time series data. And we believe the stats plan TSDR really implements this stats plan from end to end, which means from data collection, and then to data storage, and then eventually we provide the query services to pull the data from the data repository, and then we also provide maintenance capabilities for the agent data and also roll-up data. For example, the aggregation would periodically aggregate the raw data to the roll-up data, right? And purging would periodically purge the out-of-dated data. More specifically, when we say we would like to provide a generic platform for time series data, we have a few items in our mind. What does that mean for generic platform, right? The first thing, we need to create a data collection framework. What we are trying to do is whenever the data-driven application wants to get the data generated from the network, from SDN environment, they just go to TSDR, and we will be able to provide that data from our northbound APIs. And in order to do that, inside TSDR, we need to have a data collection framework that will be able to collect all kinds of data in the network, right? And we also understood it's probably not possible for us to create, to code, to implement all kinds of data collectors, right? It could be unlimited, and some of them could be even proprietary. It depends on different usage scenarios of ODL. So what we are thinking about is to create a level, a generic SPI, service API level, that will specify what we needed for the data collection. And we also summarize, there are 3 types of data collection in the network. One is actually polling, which means we, as a collector, as a collecting service, we directly poll the data from either the equipment or software or whatever to poll the data. And secondly would be pushing. Those data sources will be able to actively push to us of the data. And third one would be notification-based, which means both the data source and us will be using a messaging bus. And then we negotiate on notifications interfaces and for us to exchange the time series data. So our idea is we hope to use this SPI, service API, specify the interfaces in all the 3 categories, and we are going to provide the well-known data collectors, for example, syslog, SNMP, SFlow, NetFlow, right? And we are leveraging on the community, the entire community, to contribute your data collectors into this data collection framework. And we believe over the time, and TSDR will be able to have all kinds of data collectors to collect data in the network. So that's our goal, our vision of data collection framework. And the second one is common data model, because we understand there are different types of data, right? And different format, even, of the data from different data sources. And in order for the data-driven application to extract useful information out of it, we really need to convert all different types of data into a common data model, and then the data-driven application can extract information out of it. Just like a room of people, if everyone is talking in different languages, how do we communicate, right? How do we extract, how do we generate some intelligent ideas of it? It's probably not possible. So the common data model really gives us a way to unite all those different data types into one common thing. And after the data has been converted into common data model, we would like to provide a scalable and pluggable data repository. And scalable, definitely, it's self-explained, right? Why pluggable? Because we understand ODL could be used in different types of usage scenarios. And some people kind of like, SQL, relational database. They want to stick to it, right? And some people are open to NoSQL, kind of scalable data repository. And some use cases like IoT, probably they have to use very low-end computing systems. And we want to handle those kind of use cases too. So that's why we need to have a pluggable and also we call it elastic kind of architecture. The idea is still the same. We create a generic SPI level, and we specify all the operations, APIs needed for time series data, and we allow different types of data stores to be plugged in. And in Lithium, we have achieved both HBase and H2, which is a relational embedded kind of data store, lightweighted data store, to kind of implement this architecture. And Sharong is working on Cassandra plugin as well. So we believe this would be helpful for us to go with ODL different use cases. And after that, we will provide a generic open integration API for the data-driven application to integrate with us, for the data analysis. And the last one we want to mention is really the aggregation and purging solutions optimized for time series data, so that we can control the size of the data in TSDR. This one is for advanced analytics. Again, the next step after we get the data, we really want to extract information out of it. And there are 3 types of kind of integration. The first one is for descriptive time-based data analytics. And what does that mean? It's really just, focus on the fact of the data and try to visualize it and do some simple correlation based on time. And the second one would be predictive and prescriptive. That's more advanced data analytics, but more important, more powerful as well, including automated pattern discovery, event prediction, automated correlation among multiple data sources, and prescriptive actions based on the results, right? And the third one, that really will show the power, and that's that end goal of TSDR. That is automation based on analytics results. The last one we would like to mention is really to combine real-time and historical analytics. People nowadays always talking about real-time, how important it is. However, we want to emphasize that both real-time and historical analytics are important. Because without historical data analysis, you wouldn't be able to predict what's going to happen in the future. I'm not going through that details. This is the architecture roadmap of TSDR. And if we look at the right-hand side, we will have a data collection service, as what we mentioned earlier. It will contain a data collection SPI containing different types of data collectors. And we are going to provide the well-known ones, and we're relying on the community to contribute different data collectors into TSDR. And after we collect the data, it's going to delegate to a data transformation module that's going to convert different types of data into the TSDR common data model, which is the heart, core of TSDR. And then the data storage service will kick in, and then leverage in TSDR persistent SPI and store into different plugins, different TSDR data stores. Okay, and on the other hand, we have a data query service. We'll keep pulling data from TSDR data store, and then making it available to data-driven applications through northbound API. And also, aggregation service and purging service will continuously, periodically maintain the data in the data repository. And the very left-hand side is the transportation service, because we understand in many use cases, especially in IoT, multi-layer data analytics architecture, some edge analysis, data analysis analytics use cases need to transport the data out to more advanced back-end centralized data collection and data analysis platform services. So that's why we need to have a data transportation service, still using the transportation SPI that leverages different protocols to ship out the data from TSDR. And the very top side, very top level is the real-time processing of the time series data. So before we inserting into the data store, and after we get the data and translate it, convert it into common data model, the real-time processing will kick in. And some real-time streaming data processing technologies will be applied here, and also integrate with prescriptive analytics integration, and then eventually kicking off the automation engine to feed back the results into a network. So for example, SDN controller. Okay, now let's talk about what we have achieved in Lithium. Okay, so what we have done is the data collection service, all the collection service, storage service, query service, and aggregation service, and purging service are MD cell services. So what we have implemented are data collection service, storage service, and the data collection we collected OpenFlow stats end-to-end into TSDR. And we also used the storage service and then created the first version of TSDR data model and then store the data into both HBase and H2 plugin. Those icons will show you, which company actually contributed to different modules. This is a little bit drilled down of the TSDR integrated architecture in Lithium. So if we look at the left-hand side, those are pretty green color. That's existing helium, modules for ODL. For example, you can see the southbound plugin, which we are leveraging on OpenFlow plugin to collect the data from the switches, and then using the MD cell messaging bus, and then we'll publish the data. We'll first collect the data and store into in-memory data store, and then it will trigger the data change events, and our data collection service will get the data and to receive those data change events, and then to basically collect the OpenFlow stats. And then we are using RPC to call data storage service, and then which will first convert the data into TSDR common data model, and then leverage in TSDR data persistent layer, which will eventually store into either HBase data store or H2. And the query service and purging service are not there yet, but our design would say that these are empty cell services will eventually pull the data and make it available to northbound data applications. And also, we are going to have periodic maintenance of data using the purging and aggregation. Yeah, what we delivered, we have data collection, we have common data model, data storage, and we also have a query command. Although we don't really have full-fledged data query service, but we did provide a TSDR list command from Carafe to help user to query the data from TSDR. This is the first version of TSDR common data model. I wouldn't go to details, but what I would like to mention is, we support two types of time series data. One is the measurements, the other one is the log entries in this first version of common data model. And we also accommodated both fine-grained raw data as well as aggregated and roll-up of data. We believe this design is generic, extensible, scalable, and performance optimized. And we also used this common data model to implement our OpenFlow stats, as described there. And this is, I really would like to share with you, again, as a first release project in Lithium, right? We achieved pretty good positive performance scalability test results for TSDR. And with HBase single node support on 6 GB RAM and 4 virtual CPUs, we achieved the capability to collect data from 255 OpenV switches. We're polling at 15 seconds interval from each switch. And each poll, those are the breakdowns of how many, how many entries will be generated into the table from different types of stats. And then we also turned on data collection for 5 days, and we observed pretty steady data collection with reasonable CPU and memory utilization rates. And we accumulated 500 million rows in HBase tables, and we also have 24 GB data in HBase. And we observed query results from TSDR lists to return within 2 to 3 seconds. And we believe if we leave the testbed longer, we will get even better benchmarking results. And also, because in Lithium, we only supported single node, if we deploy in a Hadoop cluster, we would be able to expect higher benchmarking data. These are the links for TSDR. including design docs, proposals, and installation, especially installation guide and user guide, gives you very detailed information about how to install TSDR, there. And also, Sharon is going to show you the step, how easy it is to use TSDR together with ODL controller. Okay, I'm going to talk about the roadmap pretty quickly because we're running out of time. This is distributed architecture we proposed at the beginning of TSDR in Lithium. Basically, the idea is really to fully implement the stats plane concept, which means we want to free the controller just working on what it should be working on, which is the flow control and flow configuration. And then completely separate the statistic data and time series data to a separate, even MD cell instance, even a different box, different VMs, right? So still the modules, the design, the architecture will be exactly the same as a single kind of integrated architecture. The only difference is the deployment difference. And we are going to leverage on the messaging to transport the data from one MD cell to the other MD cell instance. And the roadmap, it's really a long laundry list. I just would like to mention a few things. The collection framework with more collectors support. The full-fledged query service, very important for us to integrate with the third-party analytics engine. Hadoop clusters for us to bump up the benchmarking results, and also data visualization and analytics engine integration. Sharon is working on the Grafana integration, and he will show you the kind of preview of TSDR Beryllium. And also, what we really want to do is to implement a compelling use case using TSDR. We will talk about whether it belongs to TSDR, it belongs to a different project, but that's kind of legitimate things in ODL. But we really want to show what can we do, what can we build using TSDR. Aggregation service, purging service, clustering support, distributed architecture, and also Cassandra, implementation on our roadmap. I really want to mention a little bit about beyond ODL, because our idea of processing time series data, including the platform itself, is pretty generic, right? It can handle ODL controller data, it can handle the network data, and it can even do something beyond ODL, right? For example, the IoT applications. Because we have very elastic and pluggable data store, we believe we can handle, we can be installed and deployed on very low-end computing systems, such as Raspberry Pi. And the good news is ODL controller has already been deployed on Raspberry Pi. So we can leverage the synergy there, to enable TSDR in those applications. And also NFV is really taking off now, right? We believe the same concept of TSDR can be applied in NFV too. And maybe we will find even better kind of utilization of TSDR in that environment, because our capability is really to incorporate different kinds of data, different types of data from different levels of network, and then massage them and extract intelligence out of it. Of course, it can be used in some generic kind of data center analytics, such as DDoS attack detection too. So that's pretty much it. I'm going to hand over to Sharon for the demo. That's really the fun part. Thank you.
Thank you. Hi, everybody. Can you hear me? It's working? Good. Thank you for YuLing for explaining us the background and history of TSDR. I'm going to show you a quick demo of TSDR. Some of it is developed in the past 2 weeks because I haven't had time during the Lithium time frame to develop the stuff. But luckily, I was able to do it today. So first of all, let's see how do we start TSDR and data collection stuff. Okay. Okay, so so I've got this integration already prepared with TSDR. And I'm going to load the Carafe container for ODL. Now, this is an empty Carafe container. It doesn't contain any features. So if I do a feature list, you can see that nothing is loaded. So in order to load TSDR, I would just do a feature install of the TSDR. Now, ODL TSDR all is actually the integration with H2 database. So while it's loading, and in the background, it's loading both the H2 and the TSDR framework. However, it's also loading all the collector background OpenFlow frameworks. So should be able to collect data from OpenFlow switches. I need to load also the OpenFlow plugins. So it takes some time to load the OpenFlow plugins. We can see that the data storage is already loaded, and we're just waiting for the OpenFlow plugins. Meanwhile, I'll open the front end that we created.
For H2 TSDR data store, it's really convenient for everyone to use TSDR because it doesn't require any additional installation of databases. It's different from HBase or Cassandra in the future that you really have to install those databases, right? But for H2, it's all embedded inside ODL controller. So you can just take the controller, going through the normal installation of ODL controller, and then after you do feature install of TSDR, and then you can start to use TSDR.
Okay, so the entire framework has loaded, and we can see here the inbox, out-of-the-box collectors that exist without any OpenFlow switches connected are the controller heap memory. Okay, so we can see that currently the heap memory of the controller is around 500 megs. We can see the controller CPU usage, the process of the controller CPU usage, which is currently around 0, because there are no switch, no OpenFlow switch connected, nothing is connected, everything is idle, so it's 0. And we can see the my machine currently utilization, CPU utilization, which is between 8 to 10%, I think. Now, I'm going to start Mininet, and I'm going to connect a few, around 7 switches. So in the top 2 graphs, what we can see is that the OpenFlow switch 1 of Mininet, port 2, we can see the transmitted bytes graph and the received byte graphs. So once I jumpstart the Mininet, which adjusted, we can notice 2 things. Okay, we can notice that my machine CPU is going up. Okay, give it a few seconds to refresh. Okay, you can see that my machine CPU is going up. You can see that the controller heap memory usage is going up. And in a few seconds, exactly 30 seconds, you're going to see that we are getting some received bytes and transmitted bytes statistics. Okay, you can also see that the controller CPU usage, the process itself, is also going up because now it's doing some stuff in the background. And now we started to get the data coming in from OpenFlow switch 1. from Mininet. All those graphs are pretty much dynamic. So if I want to, for example, go and instead of measuring the received bytes of OpenFlow switch 1, I can go in, and this is part of Grafana's capabilities, which we implemented in the background, an API for Grafana to use. I can, instead of using OpenFlow switch 1 and switch 2, I can switch to OpenFlow switch 2, port number 1, for example. Okay, so there's no such thing. Probably I got some typo or something. So let's go back to 1.1. Let's see. Okay, so this is port number 1 right now. The received bytes for port number 1. Okay.
Yes, sorry, again, I would like to add one comment. For all the graphs that we saw in the previous screen, actually it involves two types of data collections. One is really going through our data collection service that goes to the Open vSwitches to collect the data. The other one is we opened an RESTful API for dynamically adding, those metrics. And Sharon actually here dynamically added the CPU usage and also collected, the data from ODL processes for those memory utilization of ODL processes, and using the add metric RESTful API to insert the data into TSDR. So that really involves two types of data collection and then eventually showing in the same dashboard.
Okay, another thing that we need to mention is that the metric data is completely elastic. So if you have a third-party application that has some metric data, whatever metric data that you want to push into TSDR, we already have APIs to push that data, right? It doesn't have to be OpenFlow statistic data. If you have a proprietary statistic data or QoS data, you can also push it through the API of TSDR, and you can define in Grafana, you can define your graphs. You just need to define your what is your node ID, what is your path ID of your name, what is your metrics ID identifier for pushing in TSDR, and place the same identifier in Grafana, and it will pull the data according to your requests. Now, basically, this is the end of the demo. However, I wanted to show the flexibility of also the SPI, so the storage persistence layer. So let's say today this all data goes into H2 database, which is an SQL database. Okay, so TSDR is so flexible. So if I'm going to going here, I'm going to shut it down. I'm going to shut down the instance, okay, and re-execute it. But this time, I'm not going to load it with, and we can go back to, see, we can go back to the Grafana and can see that it's unable to pull the data. Now, if I go here and, for example, I don't want to load the HBase. I want to load the Cassandra, which is kind of no database, no SQL database. It's so flexible, so I could go literally last week. I decided, okay, let's see how flexible this SPI is. I went, literally it took me like, I don't know, a few hours, and I had a basic Cassandra storage system for TSDR. So now the Cassandra is loaded. let's see what will happen if. Okay.
So just want to add, Cassandra plugin is still kind of work in progress. So it's pretty much prototyping right now. It's not delivered in Lithium.
So
we just would like to show the flexibility
I
of
forgot to
TSDR.
load the Cassandra in the background. So just excuse me seconds. I forgot to load Cassandra. Okay.
By the way, currently we only support one data store at a time, which means in order for you to store data into a different data store, you need to uninstall the previous one and then install a new one, right? But in the future, we can look into different requirements to see if there's any need for us to support multiple data stores at the same time, so that from the request, the user can specify what data stores that you would like to insert the data, because different data stores would have different capabilities from, kind of SLA point of view, like, the latency and the speed, those kind of different things, different features to support. Right? And based on different requests, different types of requests, we can dynamically decide which data store to put into.
Yeah, also in addition to YuLing's comments, multiple data store I need when you're doing, for example, IoT. So in IoT, your end or edge devices are really weak devices. They don't have any much processing power. So you need to put something to collect the data for their statistics. However, you can have another controller, which is an aggregate of other controllers that can have the edge base or Cassandra or whatever back end to aggregate the data. So if we go back to Grafana, we can see that it's collecting the same data usage. Okay. Let's go down. Let me start Mininet.
Yeah. So now you're seeing the data actually from Cassandra instead of from H2 embedded data store.
So if I go here and I go to my Cassandra instance. And I start the CQL. And I'm going to the key space of TSDR. You can see here that inside Cassandra, I'm actually pushing the data. Okay, and we can see that the same data that came from H2 now it's coming from Cassandra, and again it's populating and working. Yes. Excuse me. Web services on my laptop?
WebSocket? No, we are not supporting it right now. But we can talk brainstorming if that's needed.
So basically, the idea is to use Jetty eventually to support the REST API for Grafana and such integration in the future for querying and retrieving the data. I tried to use the ODL out-of-the-box RPC service. However, I couldn't hack it to return the data as exactly as Grafana was expecting. So for this integration, I haven't used Jetty because I haven't had time to set up. I just created some quick quick and dirty implementation that knows how to receive the REST request and return the data in the expected format that Grafana wishes to. So literally, I've implemented a REST-conf adapter directly for TSDR, but later on, I'm going to replace it with Jetty or with something standard that will just open a different port than the ODL port, so we could handle all those integrations. And actually, the language that Grafana is speaking is something that the REST API is pretty much defined, right? It's defined by Graphite, by OpenTSDR, all those open source products. Some are commercials, also support the exact same API. So I just took the blueprint of the API and implemented it. Yeah.
Right. So if I understand the question, there are some open TSDB, those different, right, right. But I believe our goals are a little bit different. The first thing, we believe by natively integrate with ODL controller, we will be able to help with the encourage, like what I mentioned earlier, the enablement and encourage of data-driven applications directly from the controller. Because we would like to see, as again, an intelligent and smart controller. And for those data-driven applications, they have to reside into SDN controller. So by natively giving, providing the data to SDN controller, we believe we can encourage a lot of data application on top of it.
Let me answer it in a different, quite a little bit different way. Okay, so first incentive is to be able to replace the persistent data. So we could do something like IoT. OpenTSDB is using EdgeBase. Okay, I cannot put EdgeBase on my edge devices, on my IoT devices, right? So I need something that is small and quick and doesn't take a lot of memory, right? So this is one incentive. I wanted to be able to replace the persistency. Another incentive is that, let's say you are a big customer, right? And you already have your data collection, data backend for big data, right? Right. Now, you're implementing your ODL in your system, right? You want to collect the OpenFlow stats, integrate and take the OpenFlow stats, and put them in your backend, whatever big data storage you have, like EdgeBase or there's some famously Chachi stuff there, right? So we wanted something to say, okay, no problem. You want the OpenFlow stats inside your backend? No problem. We'll just implement a small SPI implementation, the same way I did for Cassandra. I can do for whatever the persistency layer that you want, or whatever third-party application that has northbound API that you want. For example, if you have OpenTSDB implemented in your company, right?
Well, OpenTSDB is
Yeah, so we just selected EdgeBase as a good candidate for scaling, but we also have H2, Cassandra.
HBase is just one example data store. It's not everything, right?
Yeah, so I've literally tested myself to see how fast I can switch from H2 to Cassandra, how fast I can switch from, how dynamically and elastic I can be to switch to whatever data store that you like. And that's the incentive.
this is great, but you've got a large estate to cover. As you can say, you've got collectors to do.
Yeah.
A whole bunch of
so YuLing will probably justify that I had the same exact question, right? When we started, I said, why we should we start? Why we
right.
shouldn't
So
we
your
use...
question is why don't we use OpenTSDB, inside our TSDR?
Big data is a large space in its own right, which you're kind of entering from OBM. Again, I was just wondering why, rather than trying to build all this stuff,
I think for myself,
So,
the incentive is in the collectors, not in the big data persistence.
so collectors are separate anyway.
What?
Collectors are a separate concern.
Yeah, but later on, let's say you are implementing your ODL on something that cannot incorporate OpenTSDB.
we probably running out of time. Let me, in summary, okay, of that questions, right? We believe, although we have OpenTSDB, although we have different monitoring tools, we have different things for the time series data. However, I don't believe there's any tool or any system that can achieve the same capability as TSDR. Because what we are trying to do is for the data-driven applications, whatever data you want, you come to TSDR. I don't believe there's anything that exists right now to claim that, because again, that comes to the data collector part. In order for a data-driven application to get the data, still people need to worry about, where to get the data, how to get the data, how to collect the data, and then how to store the data, how to make it available, those kind of things. Yeah.
But maybe another incentive is that we wanted something that can be taken apart. So I can run the service of the collectors on one machine and have the service of the storage on another machine, or have the, play with it. And I think the other products that exist out there have a focused deployment layout, right? You need this machine to have the edge base or the cluster of edge base. You need this machine to collect the data, and so on and so on. I just wanted something flexible that can collect data. If you want a persistency, out of the box persistency, it's H2. If you want something more scalable, you can use edge base or whatever back end you wish for, right? I had my doubts. I won't say I didn't have it. And we had some discussion with YuLing. I had my doubts. But thank you, everybody. Seems like
everyone, by the way, we are looking for contributors to TSDR. So if anyone's interested in contributing to TSDR, definitely, absolutely, let me know. Thank you very much.
Thank you.